Welcome to Matric Question Monday. This is episode 5. I'm so glad you could join me today. So sorry about last week not having uploaded any videos. I just had a little crisis with my internet. So today we are going to look at question 4 of the Gauteng Departmental Question Preparatory Examination of September 2015. In the first 4 episodes, we looked at question 1 to 3, and now we are going to do question 4 today. Right, so this says a pattern of triangles is formed by increasing the base of the triangle by 2 centimeter and the perpendicular height by 1 centimeter in each successive triangle. The first triangle has a base of 2 centimeter and a height of 2, and then the pattern continues in this manner. So the base is increased by 2, so this is base 2, base 4, base 6, and then obviously just continues like that. And the height is increased by 1, so this is height 2, 3, 4, the perpendicular height. This is not a very long question, it's not very difficult, so we've got a nice and easy question for today. Right, so a pattern is formed like this. In 4.1 they say calculate the areas of the first 4 triangles. Now the first 4 triangles, triangle 1 is the area of a triangle is half base times perpendicular height, which is the base is 2 and the perpendicular height is 2, so it's half times 2 times 2, and that is then 2. This is in centimeter, 2 squared centimeter, right? And then triangle 2, as I said, this is not really difficult. This is a nice and easy question for today. Is half base, my base is now 4 and my perpendicular height is now 3, so this is 2 times 3, which is 6 centimeters squared, and then triangle 3 would be half base times perpendicular height, which now my base is 6 centimeters and my height, the base just goes 2 more and the height just goes 1 more, so this is 4, which is 12 centimeters squared. Okay, and then my triangle 4 is going to be half base times perpendicular height. Now my base is going to be plus 2, there is 8, and the perpendicular height plus 1 is going to be 5, so this is now 4 times 5, which is 20. Okay, then for question 4.2, they say calculate the area of the 100th triangle in this pattern. The 100th triangle in this pattern. So I see if I expand this like that, there's now 2 ways. You can either go just get the pattern, which is plus for the areas, which is plus 4, plus 6, plus 8, so it is a quadratic pattern. Go get the quadratic patterns formula, and this is now the areas. The areas form a quadratic pattern, so then I can just get that quadratic pattern formula and then just substitute 100 in that to get the area of the 100th pattern. So that's the one option which might be most of your which might be your instinct to go and do. But I see from this a pattern. I just want to show you another method. If I look at this 1, 2, 3, 4, can you see that the area of, this is now all area of, area, so you can absolutely just go get the formula, the quadratic formula, and substitute 100 in there. But I noticed something here. Can you see that the area of the triangle is every time it's a half times, can you see if I look at the base, it's double the triangle number. Can you see that? So then this would be 2n, and then that's just one more, 2, 3, 3, 4, 4, 5. So this is just going to be n plus 1. This is sort of a shortcut to find the formula for the area of triangle n. And then a half times 2 is triangle n. A half times 2 is 1. So this is just n times n plus 1. If that what I did just now sort of confused you, you don't need to worry about this. Plus 100. And this I can quickly just put in my calculator. So I have, oh, the light is so funny, 100 squared plus 100, so it's 10,100, right? 10,100 centimeters squared. Okay, if what I did just now there confused you a little bit, don't be too worried about it, because you can also just always get this. This is just the shorter method that I saw. I'll show you the other method now. I just saw that the area of the triangle number have there's a pattern there. This base is just double the value of the triangle number, so I just put double the value of the triangle number in there, and then this number is always just one more than the triangle number, so I did that, one more than n, and then I just simplified this to get this. But if you think I'm never going to be able to see something like that, let me just quickly show you what's another option to do for 4.2, which would be the standard answer for this anyways, would be, I had the pattern, whoops, I took it off now. It was 2 and then 6 and then 12 and then 20. Okay, the areas of triangle 1, 2, 3, 4 looked like this. Okay, remember I've got 10,100. You're going to remember that, right? And then if I go and evaluate this for the 3 basic type things that you're going to look at, is you're going to look at arithmetic. So I see 6 minus 2 is 4, 12 minus 6 is 6, 20 minus 12 is 8, which is not a constant first difference, but I can see my first differences are all just 2 apart, so I can see immediately that this is a quadratic pattern. If it wasn't one of those 2, what you would do is check for geometric by taking 6 divided by 2, which is 3, 12 divided by 6, which is 2, so this is also not geometric, but I know it's quadratic. Okay, and then the method, there are various methods for finding the quadratic number patterns general formula. So if you have another method than the one I'm using now, don't be stressed, you can use your method. But if you don't have a proper method, and this is the most common method to use, I'm just going to make my second difference. I have these three formulas that you must know: 2a, 3a plus b, and a plus b plus c, which 2a is my second difference, and from that I'm going to calculate a. So I've got 2a equals to whatever is standing there. In this case, it's 2. So a is 1. And then 3a plus b is always equal to my the first one in this row of first differences, which in this case is 4, but whatever is standing there. And if a is 1, this is 3 times 1 plus b, which means b equals 1. I just took the 3 over, and then I've got a plus b plus c equals my first term. A plus b plus c equals my first term, which in this case is 2. My a is 1, my b is 1, and my c, this is 2 plus c is 2, so c is then obviously 0. Okay, and then if I go write this an squared plus bn plus c in this format with a1, b1, and c0, then my pattern looks like this. And if I substitute 100 in there, I get the 10,100 squared centimeters. All right, so that's it for today. Boys and girls, please have a lovely week. Enjoy your afternoon, and see you next week, Monday, for Matric Question Monday.